Dear students, welcome to my channel. This is 6th video on part of speech tagging. In this video, I have covered additional problems on HMM Viterbi algorithm for part of speech tagging. I have skipped HMM explanation and theoretical part here as I had already covered in my previous videos. Now HMM model is a generative model and here we determine the part of speech tag for a observed word. Here we have to do that processing when for that particular word when there is ambiguity in the part of speech tag or that word represents the multiple part of speech tag. For example, we can say the play. Now the play can be noun also, the play can be verb also. For example, if we say take the word back, so it can be represent 4 part of speech tag. It can be verb, noun, then adjective and adverb. So at that time we require to resolve this disambiguity, and for that we are using the hidden Markov model. Now here our observed word is x2 and for which we have to determine the part of speech tag, and here part of speech tag are there but it is not single, multiple tags are there, so we check the possibility with each one. Here Q1 and Q2 are the state. Q1 is previous and Q2 is the current. We already know the part of speech tag for Q1 state. Now here the ambiguity is there because for Q2 multiple part of speech tags are there, and from that tags this word get generated, that is the x2. Now here when we take when we use hidden Markov model, at that time we are using the concept of bigram as well as Bayes rule. So when we take the state transition between these two states, that is Q1 and Q2, we are using the bigram because we are taking the history of the previous part of speech tag, and here we are using the emission matrix. The formula for HMM model is probability of POS to given word and POS 1 equal to probability of word given POS 2 into probability of POS to given POS 1. So this is the bigram formula, that is count of POS 1 comma POS 2 divided by count of POS 1, and this is nothing but Bayes conditional probability rule. Bayes rule data obtained from emission probability matrix, while the bigram data is obtained from state transition matrix. Step 1. Assign the correct part of speech tag to training corpus. So sometimes in exam they give the corpus or sometimes they skip the corpus and giving the directly matrix value for emission probability and state transition probability matrix. So in my previous video I covered the example in which corpus is given and from that we start the procedure. But now in this video I am going to cover the examples in which directly emission probability and state transition probability matrix is given. Now step 1, here there is no need to go for that, we can skip this step. Step 2, creation of emission probability matrix, it is directly given, so we are just representing. Now when we see this emission probability matrix, we can find out that for the word dat, it has only one part of speech tag, that is nothing but determiner, but for girl there is a ambiguity because it can represent noun also as well as verb also. For smiles again the ambiguity is there, that is noun is 0.004 and here the VB is 0.20. So actually the ambiguity is present between noun and verb, but when we solve the problem we can take all that and also take the solution. Creation of state transition probability matrix. So states are determiner, noun and verb, and determiner, noun and verb, their transition, and we require to consider this transition with the start symbol also. So this is the state transition is given. Now the test data is that girl smiles. Now we have to determine the part of speech tag. Now ambiguity is present, for that there is no ambiguity, but for girl and smile there is an ambiguity for noun and verb. Girl indicates noun verb and smiles so indicate the noun and verb. So here if we consider by default all that tags, now total 27 ways are there because it is very difficult or we require to do according to our programming that if that particular emission or state transition probability matrix is 0, we can't take that value, but here by default I am taking all that tags and we will solve the problem. So if we take by default there are 27 ways, but when we use Viterbi decoding algorithm the path is very much efficient, so there is no need to trace all the paths to go from start to end. Now here start, and we can consider that determiner that as a determiner, that as a noun and that as a verb, and we just apply the Bayes rule and the bigram rule, and here we are getting the value. So for determiner, that as a determiner we are getting the probability as 0.2. I am not explaining this equation because in my previous video I have already took the problem and explained the equation in a very proper manner. Now here we can observe that for that word as a determiner, we are getting here the probability 0.2, here 0 and 0. It indicates that that is a strongly determiner with the probability 0.2, and remaining probabilities are 0 for the noun and verb. So what is the answer of this step? That word is a determiner part of speech tag and having the probability 0.2. Now we are carrying this 0.2 probability in the next subsequent steps. Now previous probability is become 0.2. Now here the next word is girl. So girl we require to take whether it is determiner, noun or verb. So girl as a determiner, we are getting the answer 0, that's why it is 0. For girl as a noun, we are getting the value that is 0.01, and here we multiply with the previous value and we are getting the answer which is 0.003. So this 0.003 indicates the probability, and for girl as a verb we are getting the probability as 0. So from here we can make the conclusion that girls have the part of speech tag noun. Initially there was ambiguity whether girl is verb or whether girl is noun, but now the girl is noun with the probability 0.003. Now next word is a smile. Again for smile we consider all that 3 and we carry out our previous probability which is 0.003. Now here smile as a determiner, smile as a noun and smile as a verb, and here we multiply with the previous probability answer. So smile as a determiner is 0, so answer is 0. But here the smile as a noun have a very less probability, so we are getting the answer 1, 2, 3, 4, 5, 6 means which is indicates a very small number, so we are getting this number. And smiles as a verb we are getting 0.08, we multiply with the previous probability answer and we are getting 0.0024. So here this number is greater than this, so that's why the result that smile is verb. So in this way we apply the Viterbi algorithm to determine the part of speech tag. The result of part of speech tagging after applying the HMM model is the is determiner, girl is noun and smile is a verb. Now the second problem, here also the corpus is not given, so we just require to solve the problem by emission probability and state transition is given. We just require to put the value into that particular statement. Now this is the step 1, step 2, and in step 2 there are words are like time flies like an arrow. So here ambiguity is present, so we require to check. Here when we write the emission probability matrix, at that time we can write down the unique token on this side or on this side, it does not make any difference. Now here the ambiguity is present between the time because time can be verb, noun. Here flies, that is verb or noun. Here like, it may be verb or it may be preposition, and for an there is no ambiguity, and even for arrow there is no ambiguity. So actually ambiguity is present between the time, flies, like. But when I am solving the problem, we can take all the values or we can skip that values who having the value 0 in the emission probability matrix. This is the state transition probability matrix is given, that is the how the transition occurs between the different states of the part of speech tag, and this is based on the diagram because we are considering only one word previous history. Now the data is given, time flies like an arrow. So here time is noun verb, flies noun verb, like in and noun and determiner and NN. So total ways are 8 ways are there, so this is represented by this diagram. Now we find the efficient path by the Viterbi algorithm. Now here we can take that time as a noun and verb and we will check just the probability. So now you know the formula of ways and the diagram, and we just put the value of state transition and emission probability matrix and we are getting the answer. So here we are getting for time as a noun we are getting the answer 0.08, and for time as a verb we are getting the value 0.02. Now 0.08 is greater than 0.02, so we determine that even there is ambiguity for time as a noun or verb, but here the probability of time is more, time as a noun is more, that's why here we get the part of speech tag for time word as a noun. Now we will carry out this previous probability in the next step. So previous answer is 0.08. Now next word is flies. Now flies is either verb or noun, and when we take the answer we can find out that the flies as a verb is more compared to noun, that's why with the probability 0.064, and for that we again multiply with the previous answer, that is 0.08, so we are getting 0.0064. so result is flies is a verb. Next is in, so in may be preposition or verb. Again we take the state transition and emission probability matrix, and we are getting the answer of 0.0032, and this, now this number is very small, so here we get the probability like that, like is a preposition. So this is our the answer. And after that, for the next word like an arrow, there is no ambiguity because only single speech tag is there, so we just calculate the probability. So we are just carrying out the answer. For dt there is no ambiguity, so we just take this value and multiply with the previous answer, we get this value. And our final answer, final is nothing but the arrow. Arrow, there is no ambiguity, it is noun only, so we are just calculating the previous answer. So result arrow is noun. So in this way we use the Viterbi decoding algorithm to give the correct part of speech tag to each word. So after the execution of the algorithm, time gets as a noun tag, flies as a VB, like as in, and as determiner, and arrow as a noun part of speech tag. So in this way Viterbi algorithm uses the concept of state transition and emission probability to determine the part of speech tag in an automated way. Now this exercise is given, you can try this exercise. So this exercise is from Jurovsky book. So emission probability matrix and the transition probability matrix is given, and test sample is given, that is Janet will back the bill, and here the apply the Viterbi algorithm to assign the part of speech tag in an efficient way. So for Janet it is a proper noun. For Will there are three part of speech tag, that is ambiguity is there. For back also ambiguity is there, the is also ambiguity, and bill. So the total ways are 48 ways are there. So Viterbi algorithm find a very efficient way, otherwise to check the 48 ways is a very costly problem. So all that about the Viterbi algorithm, and these are the references for this video. So in the next video I am going to cover maximum entropy model for the POS tagging problem. Thank you.